Okay, welcome everyone. We're going to begin now. So last time we started working on transformation of function, if you remember, and we worked on the vertical and horizontal shift. Okay, we just work on two different concepts, vertical and horizontal shift. Can you hear me nice and clear? Just give me the thumbs up. Okay, good. So today we are going to continue with this, and we'll be looking at the compression and stretch on the graph of a function. That is the other type of transformation that we'll be covering today. But before we get into the compression or expansion in the graph, first we want to look at even and odd functions. Okay, there are functions which can be classified as even functions, and there are some functions which can be classified as odd functions. So first, we are going to look at these two types of functions. What are even functions and what are odd functions? It is not that difficult to remember these two and differentiate between these two types of functions. When we say even functions, let me write here. When we say even functions, these are the functions that satisfy this condition. F of negative x, okay? If you plug in negative x to the function, f of negative x, that will be equal to the original function. If f of negative x and f of x are equal, then we say that the function is even function. Okay, that is only true in case of even function. And mostly the even functions are symmetrical about the x-axis. Okay, the even functions are symmetrical about x-axis. Meaning of that is, let me quickly show you a small diagram there. If I want to draw the graph of even function, say for example, there is a function like this, function whose graph is like this. This is the graph of the function y equal to x squared. And you can see that the shape of the graph on the left and right, they look similar. Okay, this is the even function. So the graph of the function, the graph of the even function, I should say, it is symmetrical about the axis. Here, I showed it is symmetrical about the y-axis. Similarly, it can also be symmetrical about the x-axis. Now, the other type of function is called the odd function, as you can see here. So odd function, let me write here. Odd function, they will satisfy this condition. If you plug in negative x to the function, f of negative x, okay, if you plug in negative x to the function, it will be opposite of the original function. It will be negative f of x. It will be negative f of x. So if f of negative x is equal to f of x, it is called even function whose graph will be like this. But for the odd function, if you plug in negative x, it will be opposite of the original function. Negative f of x means opposite of the original function. If it will be opposite of the original function, it is called odd function. And remember the graph of the odd functions, okay, graph of odd functions are symmetrical about origin. See, they are symmetrical about origin. I'm going to explain you the meaning of that. When we say symmetrical about origin, meaning of that is, if you look at these graphs here, these are the graph of odd functions here. Everybody look at it carefully. You can see we have the graph on the first quadrant and opposite of the origin is here. On the opposite of the origin, we have the similar type of structure of the graph. That is the symmetrical about origin. Or here you can see we have this graph on the third quadrant. We have reflection about origin. Here is origin. Now we have the graph on the opposite side of that here. So if you see that the graph is on the opposite side of the origin, like in the first graph here, I mean the third graph here and in the first graph, or in the second graph like this, then that is called the symmetry about origin. When we say symmetry about origin, then the reflection of the graph, which is on the first quadrant, will be on the third quadrant. If the graph is on the second quadrant, the reflection will be on the fourth quadrant. Or you can also think like this: if the graph is in the third quadrant, reflection will be on first quadrant. Okay. Or if the graph is in fourth quadrant, then the reflection will be on the second quadrant. So if the graphs are like these, then we say that the function is odd function. But the key thing here, in order to check whether the graph is the even function or odd function, when the graph is given, okay, if you want to check whether it's the graph of the even or odd function, if the graph is given, you can look at the graph and tell. If the graph is not given, if the equation is given, then you have to follow this procedure. For the even function, if you plug in negative x, it will be equal to the function. But for the odd function, if you plug in negative x, it will be opposite of the original function. So that is the theoretical part. We are going to take an example where we can verify whether the given function is even function, odd function, or it is neither even nor odd. Okay, so we're going to go to that. Before we move on, if you have any question, you can ask me now. Okay, look like there is no question. So please copy this one now, and we're going to work on it. Okay, let's work on this. So here we have this function. Let me write it down. Our function is f of x equal to x cubed plus 2x. That is the original function. Now we have to check whether this is the even function or odd function. In order to do this, what you have to do is you have to plug in negative x for x. So let's do that. So this implies if you plug in negative x, let's see what happens. If we plug in negative x, so in place of x, we are plugging in negative x. So we do the same thing on the right-hand side also. So that is equal to negative x cubed plus 2 times negative x. So we plug in negative x for x. That is our first step. And then we'll try to simplify this. And let's find out what happened after that. So f of negative x is equal to, so negative x cubed, meaning of that is negative x multiplied to negative x multiplied to negative x. So the result will be negative. 3 negatives when you multiply, that will be negative x cubed. And here we have positive 2 multiplied to negative x. Positive multiplied to negative is negative 2x. Now you can see in both of them we have the negative. So in next step, you can factor that out. So if you factor that out, you'll get x cubed plus 2x. Okay, we get x cubed plus 2x. And let's find out what we get in next step. This is equal to negative. Now look at the screen carefully. Here we have x cubed plus 2x. Everybody look at the screen. X cubed plus 2x. If you look up here, x cubed plus 2x is equal to f of x, right? X cubed plus 2x is equal to f of x over there. X cubed plus 2x is equal to f of x. So for this quantity inside the parenthesis, we can write f of x. So that is f of x. Okay, so we are getting this relation in place of x cubed plus 2x. I'm writing f of x. By doing that, we get this relation. We get this relation. So what we get here is, by plugging in negative x to the function, it is equal to, negative means opposite of the original function, opposite of the original function. So it is like this definition. See, f of negative x is equal to negative f of x. That's what I'm getting here. So if we get that, we know that the function given is odd function. So meaning of that is, the function which is given here, which is x cubed plus 2x, is the odd function. Okay, so we can write that. Please write it down. So f of x equal to x cubed plus 2x is an odd function. So this is an odd function. So all we have to do is, whenever we are asked to verify whether the given function is even function or odd function, is you just plug in negative x for x, simplify and check this final statement. If the final statement says f of negative x is equal to opposite of the original function, that is odd function. If it says, as you can see here, if we plug in negative x, if we get it equal to f of x, if it is equal to the original function, that will be even function. But if both conditions are not true, then in that case, we say that it is neither even nor odd function. Okay? Any question on this one? If you have question, you can send me through chat, or you can unmute yourself and ask. Otherwise, I'm giving you a minute or so here to finish up this writing. Vidya says, how do we simplify? All you have to do is, Vidya, we just plug in negative x for x. Wherever there is x, you plug in negative x. Okay, that's all you are doing. And then whatever operations are there, you follow those operations. For example, we have negative x cubed here, meaning of that is negative x times negative x times negative x, that is negative x cubed. Here, positive 2 times negative x, that is negative 2. Then after that, both of them are negative, we factor that out. But the key here is, what you have to do is, the key is, in place of x cubed plus 2x, here you can see x cubed plus 2x, in place of x cubed plus 2x, you have to plug in f of x. Because if you look at the original function is x cubed plus 2x, that is equal to f of x. So that's what you'll write here. Okay, so that is how you should simplify it. Prakriti said, why we are plugging in negative x? I think, Prakriti, you are a little late to the class. That's why you are confused. So when you're checking even or odd function, what you have to do is, we have to plug in negative x to the original function and see whether it is equal to original function or it is opposite of the original function. This is the definition. From this slide, we know the definition of even and odd function, and we are using that concept to determine whether the given function is even function or odd function. So if you're a little late to the class, Prakriti, you can quickly take this screenshot of this slide so that you can use it later on. Okay? Okay, so that is the first one, even and odd function. Now we'll continue with the transformation that we have started last time. We worked on the horizontal and vertical shift in the previous class, but today we are talking about the vertical straight and vertical compression. So please write this topic, and as I explain through the slide, make sure you also try to copy the definition. See, let me quickly explain you. Everybody look at the screen. I'll give you time to copy after that. First, look at the screen and try to understand the fundamental thing here. I'm going to show you this graph here, graph of f of x in this diagram here, which is here in the middle. Let me try to override that with the red color so that you can see it clearly. This one here. This graph in the middle is the graph of the function f of x. You can see this is the original function. Okay. Now, see, when we say transformation, last time what we did is, if you remember, what we did was, if there is a function f of x, in order to look at the transformation of this function, in the previous class, what we did is, we look at x plus or minus h. That's one thing. If we add h to the function, the graph will shift to the left. If we subtract h, the graph will shift to the right. We have studied that. And then if we add or subtract some k value to that function, by adding k, the graph will go up, vertical shift will be there, right, in upward direction. And if we subtract, the graph will go down. We talk about this one in the previous class, okay? But what we have not studied is, if there is a function y equal to f of x, if there is a function y equal to f of x, and if we multiply this function, let me see, if we multiply this function in front, right here by a number, say for example, if I multiply that function by some number a, okay, if I multiply this function by some number a, then there will be vertical stretch or vertical compression. This one here, the one we studied last time, that was translation. That was translation. But today, this one that we are studying here, this is called the stretch, vertical stretch. Okay, it's called the vertical stretch or vertical compression. Now, if the value of a is more than 1, everybody look at the screen. If the value of a is more than 1, that means if we multiply this function by a number like 2, 3, 4, and so on, a number more than 1, then the graph will vertically stretch. Look at this screen here. This is the function f of x. If we multiply by 2, you can see 2f of x. Then this graph in green is the vertical stretch. Because we multiply by 2, the graph becomes taller. Okay. If you see the graph is stretched vertically along the y-axis, that is possible when we multiply a given function by a, where a is greater than 1. So that is our first condition there. When a is greater than 1, you can see if a is greater than 1, then the graph will be vertically stretched. Similarly, if we multiply this function by a positive number less than 1, see, in the second condition, between a number between 0 and 1 means a number is a positive number, like 0.2, 0.3, and so on. If we multiply by a number between 0 and 1, a positive number between 0 and 1, the graph will be compressed. It will be shorter. For example, for the same function f of x, if we multiply by 0.5, 0.5 is a number between 0 and 1, the graph becomes shorter. Down here in orange color, you can see the graph of the function 0.5x, and that is called the vertical compression. The graph becomes shorter, just like you compressed from the top. Okay, when you multiply by a number between 0 and 1, the graph gets shorter, just like you are compressing from the top. But if you multiply by a number greater than 1, it is just like you are pulling the graph up and making it thinner and taller, which is called the vertical stretch. And if we multiply by a number which is less than 0, then it can be the combination of both vertical stretch and compression along with the reflection. Because if we multiply by a negative number, here is less than 0, the graph will go in the downward direction. That will be the vertical reflection, which we have already seen. So please copy the definition. I'm going to give you about a minute here. Then we are going to move on to example. Also, as you are copying, if you have questions, you can also ask me. Okay, I hope you are almost done copying it, but Prakriti has a question here with this second bullet point. So if you look at this second bullet point, let me try to explain this with the help of a number line. See, when we have a number line, we'll have a 0 here, maybe 1 here, and other numbers on the other side. Here it says your a value, the value with which you are multiplying a function, is between 0 and 1. It is between 0 and 1. That is, the number is here. Let me show you in red. Number is here, okay? The numbers which are here, these are the numbers more than 0 and less than 1. That is the meaning of that. A is between 0 and 1. And if you think of the numbers here, the numbers here are like 0 0.1, maybe 0 0.2, 0 0.3, and so on, okay? So if we multiply by numbers like this, like the one shown here, we are multiplying the original function by 0.5. 0.5 is a number between 0 and 1. So if we multiply by a number between 0 and 1, in that case, the graph will be compressed or graph will be shorter. That is the meaning of that. Does it make sense, Prakriti? Okay, good. Any other clarification that you want? Anybody in the class? Before we move on to example? Aditi, are we done copying it? Yes, okay, good. So let's go to the example then. Here is the example based on the compression. So I'm going to give you a minute to copy this one. You can see it's a long question. So write down the question, sketch the graph, and we're going to talk about it after that. Okay, I hope you are done copying it. Let's talk about it now. First, let's read through the problem, try to understand what is given here and what we are asked to do. A function models the population of fruit flies. So the graph given here is the graph for the population of fruit flies. A scientist is comparing this population to another population whose growth follows the same pattern. When we say growth follows the same pattern, it increase like that, decrease like this, and also decrease like this. Okay, that is the meaning of the same pattern. So growth follows same pattern, but twice as large. See, growth follows the same pattern. Same pattern is there, okay? But the growth rate is twice as large. Meaning of that is, if we want to sketch the graph of that other population, it will be a similar graph, but stretched twice. Okay, the graph will be stretched twice. So we are asked to sketch that population or sketch that graph. So what we know is, if, let me write here, if P of T is original population, as it is mentioned here, P of T, then the other population that we are talking here, right? The other population is 2 times P of T. The reason is it has the growth rate twice as large. So meaning of that is the value of A is 2. So value of A is 2. A is equal to 2. That's why we multiply by 2. So it becomes 2 times TT. Okay. So we need to sketch the graph of that by multiplying by 2 everywhere. So you can see if we multiply by 2, look at the screen here. So here we have 0 through 1. If we multiply this 1 by 2 to make it double, 1 times 2 will be 2. It will be here. So that will be the first point. So try to understand this very properly. Okay. Here is a 1. If we multiply that by 2, it will be here. Now look at this point here, the other point here, this corner where I am pointing. You can see that the value of y is a 3 there. If we multiply it by 2, because we are multiplying everything by 2, it will be 6. So it will go up there, 6. Like that. Okay, I hope you are following so far. We get up to there. If you have a question, you can ask me. Now let's look at this corner here. This corner, for this corner, the height of the graph is a 2, as you can see. It is a 2. If we multiply it by 2, because we are doubling everything, it will be 4. So it will go up to 4 there. Like that. So it's decreasing like this. Hold on, that's a straight line there. Like that. And then finally, if you look at this last point here, here is that last point. For this last point, everybody look at the board now on the screen. You can see for this point, the y value is 0, right? You can see the y value is 0 or the population is 0. So if you multiply 0 by 2, that will also be 0. That means the next point will also be 0. So from there, the graph will come down to the same point. Okay, so that is the graph of the function because this is 0. 0 times 2 is a 0. So you can clearly see your original function was P of T. And then this new function is for 2 times P of t. That is for the population whose growth is twice as large. That will be 2 times P of t. Okay, if you have any question, you can unmute yourself and ask me, or you can send your question through chat before we move on to next example. Okay, before we move on, if you look at this graph here, you can see that here is our original graph. Okay, here is the original graph, which is given in blue color there. And what we did is we multiply the original graph by 2, and you can see that the graph becomes taller, right? It becomes taller. So as we are multiplying by a number greater than 1, you can see that the graph gets stretched, right? It is stretched. That's why it is taller. The reason is very simple. We are multiplying by a number greater than 1. That's why the graph becomes taller, or the graph gets stretched. Okay, let's look at one more application of this stretch that we have studied today. And here is that. Please copy this question and we'll talk about it. Okay, let's talk about it now. So in the previous problem, what we are doing is we were multiplying by 2 because it was the problem of vertical stretch and the values were doubled there. Okay, every value on the graph were doubled. But now you can see we have the function given in the form of a table. And this function is the function y equal to f of x. Now what you have to do is we have to create the table for the function which is half of f of x. So you know that if we multiply by half, half is a number between 0 and 1, right, Prakriti? Half is a number between 0 and 1. That means in this case, the graph will compress. We are not asked to graph, but it is definitely going to compress because we are multiplying by half. We are just asked to create the table. So let's create that table. So what we'll do is first we are going to write the same x values because X values will not change. So X values are 2, 4, 6, 8. These are the X values. Now we need the f of X, but in this case, it is not f of X, it is half of f of X, which is denoted by g of X. So we write that as g of X. We make a table now. And we need to fill this table with the new values, which are half of the original y values. So for example, look at the first value here. First value is 1. We need half of 1, half of f of X. So half of 1, which is same as 1 divided by 2, or 0.5. Half of 1. Next value is 3. So we need half of 3. Half of 3, which is 3 divided by 2. And when you divide 3 by 2, it is 1.5. 1.5. Now, if we go to next value is 7. So we need half of 7. Half of 7 is 7 divided by 2, or 3.5. So this value here is 3.5. And finally, the last value is 11, but we need half of 11, which is equal to 11 divided by 2, or 5.5. 5.5. So you can clearly see if we multiply the original function by half, the y values, you can see here we have the original y values 1, 3, 7, 11. The y values will also be half. When the y values get half, you know the y values are along the y-axis. The y values will go down. That means the graph will be compressed. Okay, the graph will be compressed. If we are asked to draw the graph of this function, you'll see the compressed graph. But here we are just looking at the y values. You can see the y values become half of the original y values because we are multiplying the function by half. But in the previous example, as we are multiplying every single y values by 2, they are getting doubled. Okay, so when the numbers get larger, the graph will stretch. And when the numbers get smaller, like here, the graph will be compressed. Okay, that is the key there. That's why we said here in the beginning, if we are multiplying by a number greater than 1, the graph will stretch. And if we are multiplying by a number between 0 and 1, like the decimal number, then the graph will be compressed. That is the meaning of that. Okay, if you have any question on this, you can ask me now. You can unmute yourself and ask, or you can send through chat. Okay, look like there is no question. So we'll move on to the last example for today. Please copy this question now. Vidya asks, is that an odd function? Vidya, are you talking about this graph or the previous example? This one. Yeah, this is odd function. As you can see, this is odd function because the reflection of the first quadrant is in the third quadrant. So definitely this is odd function. Very good. Okay, let's talk about this now. You can see the graph g of x, the graph which is given here is the graph y equal to g of x. Let me write that down. This is the graph y equal to g of x. That is the graph. The graph g of x below is the transformation of the parent function f of x equal to x cubed. There is the original function, which is f of x equal to x cubed. When we do the transformation of this one, we get this graph. This graph is not given. F of x equal to x cubed is not given. If you want to see how the graph will be for that, let's quickly do something. X, f of x. Let me put some values here. The values like -1, 0, and then 1. And we can find the corresponding y values. So if you cube the first value, -1 cubed, that will be -1. 0 cubed, that will be 0. And then 1 cubed, that will be 1. And if we use these points to create the original graph, you'll see the original graph. Let me show you here by plotting those points. Okay, 0, 0, that will be in the origin right here. 1, 1 will be here, this one. And then -1, -1 is right here, right? -1, -1 is right there. So if we draw the graph, the original graph will be like this. It will go like that. And on this side, it is going like that. That is the original graph. So this graph in red is the graph of the function y equal to x cubed. Okay, graph of y equal to x cubed. Now, what do we see? Everybody look at the board very carefully. You can see this red graph on the first quadrant. You can see the red graph is above the blue graph. Okay, and when we do the transformation, the graph has gone down. The new graph has gone down like that. That means the graph of g of x is obtained by compressing the graph of f of x, right? By compressing this x cubed, we'll get this one. If we compress down the red graph, it will come to this blue graph on the first quadrant. Okay, so meaning of that is here is the compression. So in order to do the compression, we multiply by a number and we have to find that number because we are asked to find its equation. So this is how you can set up the equation. Now what we can do is your g of x, your new function, g of x will be some constant a multiplied to f of x. If you multiply the original function by some constant, we get that. And we need to find this. Okay, we need to find that a. Or we can write like this, g of x is equal to a times f of x is x cubed here. So it involves a little bit of math, as you can see. Now, in order to find the value of a, we have to choose one point on the graph of this function. You have to choose one point on the graph of here where I'm pointing. This point there. This point is 2, 2. You can take any point that has a proper coordinate like this. So this 2, 2 is on this graph of g of x. That means the value of g of x is 2 when x is also 2. When x is also 2, that is the meaning. Y value is also 2 and x value is also 2. If we plug that in, we'll be able to find the value of a. Okay, so let's solve this equation and find the value of a. 2 equal to 2 cubed here, 2 cubed is 8. 8 times a. And if we want to find the value of a, we have to divide on both sides by 8. So we can do that. Divide by 8, divide by 8. So this implies the value of a is equal to, here you can see 8 and 8 gets cancelled. And here it is 2 over 8, which is same as 1/4. 2 over 8, which is same as 1/4. So your new function g of x, see g of x, if you look at the screen one more time, here you can see g of x. G of x is ax cubed, but we got the value of a is 1/4. So it is 1/4 x cubed. So my answer is 1/4 x cubed. And you know, this 1/4 will make sense because, see, 1/4 is a number between 0 and 1. 1/4 is 0.25, right? If we multiply by 0.25, you know that the graph will be shorter. It will shrink down. And that's what is happening here. Okay? So when the graph is given and we are asked to find the equation, you should know exactly what transformation is going on and use that transformation properly to find the value of unknown to define that transformation. Okay? So all other examples that we have done today does not involve any serious math, but this one involves a little bit of math to find that unknown quantity here. So this is how we can handle a problem like this one. Instead of giving the original graph, they are given the transformed graph, and we are asked to find the equation here. Okay, finish up your writing. If you have questions, you can send me through chat. There is a question in the chat. The question says, how did you come to choose the point 2, 2? I need to choose any point on this graph, okay? Any point on this transformed graph, whichever point makes sense, I have to select that. You can see here the only point that is possible. This is right at the intersection of 2 and 2, so I choose that. Or you can also do this point on the other side. That is also, you can see this point on the other side. That is -2, 2. You can also choose that, but other points are difficult to read. That's why I'm not choosing the other points. You have to select the point that you can read properly from the graph. That's why I selected 2, 2 here. I would have selected -2, -2 also to get the same result. That is, if you choose that point, then also you will get 1/4. Okay, so any other questions? Okay, look like there is no other question. So before we end the class, from the mastery exercise, you will see that if you go to the learning management system, you'll see the copy of mastery exercise 4. Okay, and from there you'll solve. You did question number 1 through 4 last time. Now you'll solve up to number 7. The attendance link is now active, so you can also complete the attendance before you leave. Make sure you refresh the page if you don't see that attendance link in the learning management system. Okay, I'll see you all next week. Enjoy your week and see you next week. Take care, everybody.
I have a question.
Yes, who is that?
Karina.
Karina. Yes, Karina.
So, for the fourth one, for the copy, do we have to do questions 1 through 4 again?
No, you don't have to. You just solve questions 5, 6, and 7.